A star hidden in the constellation Scutum defies our understanding of stellar physics. Scuti is 1,700 times the Sun's size, yet its true dimensions remain fiercely debated by scientists. But its unstable core suggests a future supernova that could outshine the entire Milky Way. Located 9,500 light-years away, this cosmic giant's instability raises urgent questions about our galaxy's fate. Its existence forces us to confront the fragility of our place in the universe. Imagine a star so vast that its surface would stretch beyond the orbit of Jupiter if it existed in our solar system. Scuti's sheer scale warps the very fabric of space, its gravity distorting light and time. Yet, despite its colossal size, it's invisible to the naked eye, buried under layers of cosmic dust. This paradox haunts astronomers. How can something so enormous remain hidden? The answer lies in its chaotic nature. The Scuti pulses violently, shedding material in violent eruptions that obscure its glow. Each heartbeat of this star is a death knell for nearby planets, its radiation capable of stripping atmospheres and boiling oceans. Even at 9,500 light-years away, its potential death could ripple through the cosmos. A supernova from Scuti would flood the galaxy with gamma rays, triggering cosmic storms that could disrupt Earth's ozone layer. We'd see it as a blinding beacon in the night sky, brighter than any star, for weeks, but by then it would be too late. Its death would already have rippled through the universe. Scientists are terrified, not just by its size, but by its unpredictability. Scuti is a ticking time bomb, and we're still trying to figure out when it'll go off. A star 1,700 times larger than the Sun exists 9,500 light-years away. It could obliterate Earth if it exploded. Scuti, hidden in the constellation Scutum, is so massive it defies our understanding of stellar physics. Scientists still argue over its true size, but its instability hints at a future supernova that could outshine the Milky Way. This star's existence forces us to confront how fragile our cosmic neighborhood truly is. The first glimpse of Scuti came in 1907 when Canadian astronomer Harold Hogg, working at the University of Toronto, catalogued it as a variable star during a survey of Scutum. But its true scale was buried beneath layers of interstellar dust, a veil that obscured its monstrous size for decades. Hogg's notes described erratic brightness fluctuations, a clue that this star was not just large but violently unstable, a red hypergiant teetering on the edge of collapse. Then came the Hipparcos satellite, launched in 1989, which measured Scuti's distance as 9,500 light-years, a revelation that placed it in the far reaches of the Milky Way. Yet its size remained a mystery. Hipparcos's data showed it was massive, but its irregular shape and pulsations made precise measurements impossible. The star's surface wasn't smooth, it was a chaotic boiling cauldron of gas and dust, expanding and contracting like a dying heartbeat. In 2007, David Lambert of the University of Texas at Austin analyzed Scuti's chemical composition and found something unsettling, an unusually high abundance of heavy elements. This suggested the star formed in a region of the galaxy rich in metals, a clue to its origins but also to its instability. Yet, despite its colossal size, Scuti is invisible to the naked eye, dimmed by its own dust shell and distance. The paradox is maddening. How can something so enormous remain hidden? The answer lies in its violent, self-destructive nature. Every pulse of Scuti is a death sentence for anything near it, its radiation capable of vaporizing planets in an instant. And yet, we're still watching, helpless, as it inches toward its inevitable end. In 2013, a study led by Roberta Humphreys of the University of Minnesota used data from the Spitzer space telescope to confirm Scuti's radius exceeds 1,700 solar radii, reigniting debates about the upper limits of stellar size. This revelation made scientists uneasy. How could a star so massive remain stable? Scuti is classified as a red hypergiant, a rare class of stars marked by extreme instability. Its surface pulses violently, shedding material in violent eruptions that obscure its glow and complicate measurements. The star's luminosity is 340,000 times that of the Sun, yet its sheer size suggests it's losing mass at an unprecedented rate. This paradox, how can something so luminous and massive be so unstable, has left astrophysicists baffled. The study also highlighted Scuti's role as a semi-regular variable star, its brightness fluctuating due to pulsations and mass loss. But the biggest mystery remains. If Scuti is so unstable, why hasn't it collapsed or exploded yet? Its estimated mass is around 30 solar masses, but its irregular shape and chaotic behavior make precise measurements nearly impossible. Some models suggest it's nearing the end of its life, destined to explode as a supernova or hypernova in millions of years, yet its survival so far defies expectations. The implications are staggering. Scuti's existence challenges our understanding of how massive stars evolve, die, and reshape the cosmos. Every pulse of this star is a warning. The universe is vast, indifferent, and full of things we barely comprehend, and Scuti, it's just one of them. The Spitzer data revealed a massive glowing envelope of material ejected by the star, fueling ongoing research into mass loss mechanisms. Even today, with the James Webb Space Telescope, scientists are still refining their measurements. But the questions remain. What's holding Scuti together, and when will it finally meet its end? Its very existence is a reminder that the cosmos is full of things that defy our understanding, and that we are but fleeting observers in the face of such enormity. Scuti's existence is a cosmic anomaly that warps our understanding of stellar evolution. As a red hypergiant, it's teetering on the edge of collapse, its core burning through fuel at a rate that should have already torn it apart. Yet it persists, defying models that predict such stars should implode or explode within a fraction of their lifespans. Its sheer size, over 1,700 times the Sun's radius, suggests it's losing mass at an unprecedented rate, shedding material in violent eruptions that obscure its glow and complicate measurements. But here's the terrifying part. Despite this extreme mass loss, Scuti still shines with 340,000 times the Sun's luminosity. How? Its outer layers must be expanding so rapidly that they're somehow generating energy, breaking the laws of physics as we know them. Infrared observations from the Spitzer Space Telescope revealed a massive glowing envelope of ejected material, a dust shell so vast it dwarfs the star itself. What's fueling this outflow? Scientists suspect Scuti's internal chaos, pulsations that rip through its surface, tearing apart its structure and spewing gas into space. The James Webb Space Telescope, in the 2020s, has since mapped these ejections with unprecedented clarity, revealing a chaotic pre-supernova phase that no model predicted. Every pulse of this star is a death sentence for anything nearby, its radiation capable of vaporizing planets in an instant. Yet it's still here, still burning, still defying the inevitable. The universe doesn't care about our fragile existence. Scuti's fate is sealed, it will explode. And when it does, it will outshine the Milky Way. But we'll be too far away to see it until its light reaches us in millennia. The question isn't whether it will end, it's how long we'll be forced to watch it teeter on the edge of oblivion, knowing we're powerless to stop it. Scuti's legacy is etched into the fabric of astrophysics, a cosmic benchmark that forces scientists to confront the limits of their models. Its existence challenges theories of stellar feedback, proving that hypergiants like Scuti are not just dying stars, but engines of cosmic transformation. As it sheds material at an unprecedented rate, it floods the interstellar medium with heavy elements, iron, gold, and the building blocks of planets. Yet the mechanism behind this mass loss remains elusive. Is it the violent pulsations, the chaotic magnetic fields, or something deeper, something we've yet to name? Every ejected particle is a clue, but the puzzle remains unsolved. The sheer scale of Scuti evokes a visceral terror. Imagine a star so vast that its surface would stretch beyond Jupiter's orbit if it existed in our solar system. Its gravity warps space, its light bends time, and yet it's invisible to us, hidden behind a veil of dust that dims its brilliance. This paradox, the most luminous star in the Milky Way, yet unseen by human eyes, haunts astronomers. What does it mean for our understanding of the universe? Are we blind to other giants, other anomalies lurking in the dark? The questions are endless. Why is Scuti so large? How long will it teeter on the edge of collapse? And when it finally explodes, will it be a supernova or a hypernova, tearing apart its surroundings in a burst of gamma rays?